Welcome back to Geometry, Measurement, and Probability. In this video, we'll be looking at section 14.1, where we talk about translations, rotations, and tessellations. So let's get started. Any rigid motion that preserves length or distance is called an isometry. A translation is one type of isometry, and a transformation is any function from a plane to itself that is a one-to-one correspondence. Let's start by focusing on translations. So translation is a motion of the plane, and it moves every point of the plane a specified distance and a specified direction. Think about a child going down a slide. Now, a couple of things about translations. A figure and its image are congruent. And if I have a line, the image of a line is a line that is parallel to it. Now, when we think about our translation, we need to think about what happens to a single point. We'll call that point A, and A prime is what we call the image of that point after the translation. So a slide arrow or a vector is how we map the translation. It's going to tell us how far we move, and it also tells us what direction or directions to move. So let's look at example 1. We want to take AB under the same translation that moves x to x prime. So let's first think about what happens to move x to x prime. We move down 2 and then right 2. So I'm going to move A down 2 and right 2, and that makes my new point A prime. I do the same thing with B. I move B down 2 and right 2, and that makes my point B prime. And connect your 2 points. Now, in a Cartesian plane, we have our translation and we move x, y to x plus a and y plus b, where a and b are real numbers. Now, here's how we write this in symbols. You'll notice the arrow. So we have x, y, and the arrow, and x plus a, comma, y plus b. In a Cartesian plane, we write our points as ordered pairs. So even our translation is written as an ordered pair. The arrow denotes our moves to. So look at the figure on your screen. Now my points, I'm going to go ahead and label. Generically, I call the points x, y. A is the point -2, 6. B is the point 0, 8. And C is the point 2, 3. Now I want to label my image points. So A prime is the point 3, 4, B prime is the point 5, 6, and C prime is the point 7, 1. Now notice each point moved to the right 5 and moved down 2. So I want to think about that in terms of x and y. Notice that -2 plus 5 is 3. That's that right 5. 0 plus 5 is 5. 2 plus 5 is 7. So I'm looking at the x coordinates, and I added 5 to each of those x coordinates. Now let's look at the y coordinates. Start with A. 6 minus 2 is 4, and the minus 2 comes because I moved down 2. 8 minus 2 is 6, and 3 minus 2 is 1. And again, the minus 2 is because I moved down 2. So we moved right 5 and down 2. And we denote that as x plus 5, comma, y minus 2. In example 2, we are asked to find the coordinates of the images of our vertices in our quadrilateral, and we'll be given several different translations. So let's start with part A. We have x minus 2 and y plus 4 denotes our translation. So for A prime, that's my image point. I start with the x coordinate of A, which is 0, and 0 minus 2 is -2. The y coordinate of A is also 0, and 0 plus 4 is 4. So I used my formula that's given in the translation. I subtracted 2 from the x, and I added 4 to the y. Now look at B and B prime. The x coordinate of B is 2, and 2 minus 2 is 0. The y coordinate of B is 2, and 2 plus 4 is 6. Move to C and C prime. So 4 minus 2 is 2, The y-coordinate of C is 0, and 0 plus 4 is 4. And last we have D and D prime. 2 minus 2 is 0 for that x-coordinate in D prime. And for our y-coordinate, negative 2 plus 4 is 2. Now look at part B. We have a slide arrow that takes A to A prime. And A prime is the point negative 2 comma 4. So I want to think about what do I have to add or subtract from x and y to get that new point. Well, 0 minus 2 is negative 2, so I'd have x minus 2. And 0 plus 4 gives me 4, so I'd have y plus 4 would denote that translation. Notice that this is the same translation that we saw in part A. Now look at part C. This time we have a slide arrow from S to S prime. S is the point 4, negative 3. And S prime is the point negative 2, 1. So 4 minus what makes 2? Well, 4 minus 2. So we have x minus 2. And I need to think about my y's. Negative 3 plus what makes 1? Well, that would be 4. So y plus 4 would denote how we move the y's. This again is the same that we saw in part A. Now this brings us to our rotation. So rotation is a transformation of the plane. And what we think about holding one point at the center fixed and rotating the plane about this point a certain amount in a certain direction. So you'll be given typically a number of degrees and either clockwise or counterclockwise. If you're not told counterclockwise or clockwise, we always go counterclockwise. So look at this image here. In A, we have our original image, and O is our turn center. And you can think about putting your finger on O and rotating that triangle, and you'll see the image in part B. So in example 3, we want to find the image of our triangle under the rotation shown, and we have a center of O. Now notice that this rotation is 90 degrees counterclockwise. My points will stay the same distance from O, but each are going to rotate 90 degrees. So B is 2 from O, and if I rotate that 90 degrees, that means that B is going to be above O, and so we have B prime for our image point. Now look at A. So A is 1 to the right and 1 above O. Think about taking the black line that I just drew and rotate that line 90 degrees, and you'll see where A prime comes. Then let's do the same thing for C. C is 3 to the right and 1 above O. I want to take this blue line now, and I want to rotate that blue line 90 degrees, and we get our C prime. Connect your image points for your triangle. In example 4, we're just asked to rotate the specified degrees. We're not given a center. And because we're not told clockwise or counterclockwise, we always assume counterclockwise unless it's specified. So 90 degrees counterclockwise in part A turns that rectangle up and down. In part B, we have 270. Well, 270 is a little bit more difficult to see, so I'm going to rotate it in stages. If I rotate that figure 90 degrees, you'll see the image. Then if I rotate another 90 degrees, it would be 180, and then 270, you'll see that final image. A rotation of 360 degrees about any point moves any point and the figure to itself, so it's called an identity transformation. And a rotation of 180 degrees about a point is called a half turn. Now rotation or turn symmetry is when the figure comes back to itself when it's rotated. We looked at this in section 11.2. So look at example 5. We're asked in example 5 to figure out how many degrees of rotation symmetry each figure has. Now remember, 360 degrees will take any figure back to itself. So I'm going to start with that 360. Notice that this is an equilateral triangle. It has 3 vertices, so I divide by 3. Type this into your calculator and you get 120 degrees. Next, we have a pentagon. Again, 360 degrees will take any figure back to itself. This regular pentagon has 5 vertices, so I divide by 5, and that gives me 72 degrees. Join me in our next video as we talk about tessellations of the plane.